Hello everyone. In this video, we shall discuss the half-angle identities and some examples that would require the use of these identities. So whenever we have something like sine of alpha over 2 or sine of 1/2 times alpha, then this particular expression would need a half-angle identity, or we can make use of a half-angle identity to get an expression or a value that will be equivalent to this one. Now, these half-angle identities are actually derived from the double angle identity for cosine. So if we are going to consider cosine of 2 times a, and using the double angle identity for cosine, then we get 1 minus 2 times sine square of the angle a. Now, if you want to solve for sine square of a, then we will transpose negative 2 sine square a to the left side, and we will transpose cosine of 2a to the right side. So we get 2 times sine square a is equal to 1 minus cosine of 2a. And then dividing both sides by 2 will give us sine square a is equal to 1 minus cosine of 2 times a all over 2, which is this particular expression. Now, solving further for sine A, we make use of the square root property. So we get sine A is equal to positive negative square root of 1 minus cosine of 2 times the angle A over 2. Now, in order to achieve the half angle parameter, then we have to replace angle A by some angle alpha divided by 2. This is to make sure or to ensure that there will be a half angle parameter inside the sine function. So if you are going to use capital A equals alpha over 2, that would mean that 2 times capital A is equal to 2 times alpha over 2, which is simplified as alpha. So which means the angle A will be replaced by alpha over 2, and the angle 2 times A will be replaced by alpha. So this gives us the formula for sine of alpha over 2. Now the question here is, which between the positive and negative sign shall be adopted when we are evaluating sine of alpha over 2? Now to answer that question, then we need to know the position of the terminal point of alpha over 2. So if the terminal point of alpha over 2 is in quadrant 1 or quadrant 2, then that means we're going to use the positive square root. If the terminal point of alpha over 2 is in quadrants 3 or quadrant 4, then we have to use the negative square root. This is because the sine function is positive whenever the terminal point is in quadrants 1 and 2, and it is negative whenever the terminal point is in quadrants 3 or quadrant 4. Now, for cosine of alpha over 2, then again, we have to use the double angle identity for cosine, but this time we have to use the formula 2 times cosine square of angle A minus 1. And then we're tasked to solve for cosine of A. So to solve for cosine of A, we will transpose negative 1 to the left side. So we get 1 plus cosine of 2 times A, which is equal to 2 cosine square A. If we divide this by 2, then we get cosine square A is equal to 1 plus cosine of 2 times A over 2, which is this expression. And then, solving for cosine of A, we apply the square root property. So cosine of A is equal to positive negative square root of 1 plus cosine of 2A over 2. And then similar to what we did in the previous slide, we will let A to be some angle alpha divided by 2 in order to achieve the half angle parameter. So the angle A will be replaced by alpha over 2, while the angle 2 times A will be replaced by alpha. So this is the formula for cosine of alpha over 2. And again, the positive and negative sign will depend on the terminal point of alpha over 2. If the terminal point of alpha over 2 is in quadrants 1 or 4, then we have to use the positive square root. Now, if the terminal point of alpha over 2 is in quadrants 3 or 2, then we have to use the negative square root. It's because cosine is positive in quadrants 1 and 4, and cosine is negative in quadrants 3 and 2. Now, for tangent of alpha over 2, we can make use of the ratio identity. We know that tangent is sine over cosine. So if we are going to use sine alpha over 2 over cosine alpha over 2, replacing these by the respective half angle identities, we get the following expression. So it's positive negative of the square root of 1 minus cosine of alpha over 1 plus cosine of alpha. And then again, the plus or minus sign will depend on the terminal point of alpha over 2. So if the terminal point of alpha over 2 is in quadrants 1 or 3, then we have to use the positive square root. But if the terminal point of alpha over 2 is in quadrants um, 2 or 4, then we have to use the negative square root. Now, this tangent of alpha over 2 has another set or sets of formulas. So that can be derived by multiplying the radicand here by 1 plus cosine alpha over 1 plus cosine alpha, or by multiplying this radicand by 1 minus cosine alpha over 1 minus cosine of alpha. So to solve those other formulas for tangent of alpha over 2, so we have to multiply this expression by 1 minus cosine of alpha over 1 minus cosine of alpha. So since we're multiplying the numerator and denominator by the same thing, it's like multiplying the whole expression by 1. And we know that an expression times 1 is actually itself. So we're not changing the value or the sense of this particular expression. The 1 minus cosine of alpha times 1 minus cosine of alpha is 1 minus cosine alpha quantity squared. However, for 1 plus cosine of alpha times 1 minus cosine of alpha, we can make use of a plus b times a minus b in algebra, which is simplified as a square minus b square. So that's going to be 1 minus cosine square of alpha. And then using the Pythagorean identity, this 1 minus cosine square of alpha can be replaced by sine square of alpha. So since both the numerator and denominator inside the radical are both squares, then we can extract them outside of the radical, and that gives us 1 minus cosine of alpha over sine of alpha. So this is another formula for tangent alpha over 2. So similar solution, no? But this time we multiply the numerator and denominator by 1 plus cosine of alpha. So the numerators, when we multiply, we get the product 1 minus cosine square of alpha. While the denominators will be 1 plus cosine alpha quantity square. Now this thing again can be replaced by sine square of alpha. And since both the numerator and denominators are squared, then we can extract them outside of the radical sign, which means that tangent of alpha over 2 is also the same thing as sine of alpha over 1 plus cosine of alpha. So let's illustrate some application or illustrations of these half angle identities. So let's fill in the missing information inside the parentheses. So this cosine of blank is equal to square root of 1 plus cosine 24 degrees over 2. So in our formulas, this can be treated as angle alpha. So if alpha is equal to 24 degrees, then we have to get alpha over 2 for this parameter. So alpha over 2 is 24 degrees over 2, which is 12 degrees. So this one is 12 degrees. And then we have sine of 48 degrees equals the square root of 1 minus blank over 2. So from the form, this means that we're using the half angle identity for sine. So this one must be cosine of something. So this 48 degrees is your alpha over 2. So if alpha over 2 is 48 degrees, that means alpha is equal to 2 times 48 degrees, which is 96 degrees. So this blank here must be cosine of 96 degrees. And then for the last bullet, tangent of 6x is equal to sine of blank over 1 plus cosine of blank. So since alpha over 2 is equal to 6x, then this must be alphas. So alpha is equal to 2 times 6x, which is 12x. So this missing information must be equal to 12. Now to verify the sum of the identities, let's go back to our slides here. So let's suppose that we're looking for the value of cosine of 5 pi over, let's say, 12. Cosine of 5 pi over 12 can be, um, it can be written as cosine of 5 pi over 6 over 2. So that means alpha is equal to 5 pi over 6. So this one is our alpha is 5 pi over 6. Now, 5 pi over 12, it's an angle in the second quadrant. Okay, no. 5 pi over 12, that's actually, is it between 0 and pi over 2? 1 half. This is, yes, this is between 0 and pi over 2. So cosine 5 pi over 12, this must be in the first quadrant. I'm sorry for the error. So this is in the first quadrant. So if this is in the first quadrant, then uh, that means we are going to use the positive square root. Okay, so we have to use the positive square root. So this will be 1 plus cosine of 5 pi over 6 all over 2. So that's how we evaluate these trig functions having um, half angle parameters. Okay, now, so since you already know how to evaluate them, let's have an example wherein we prove an identity. So let's prove this identity. Now, the left-hand side is sine of angle A over 2 minus cosine of angle A over 2 quantity square is equal to 1 minus sine of A. So in here, the left-hand side now can be written as square root of 1 minus cosine of A all over 2 minus square root of 1 plus cosine of A all over 2 quantity square. So this square here, we will expand this binomial and we get 1 minus cosine of A over 2 and then minus twice the product of the following. So the following radicals will have the product square root of 1 minus cosine square A over 2 times 2 is 4. And then the square of this one will be plus the fraction 1 plus cosine of A all over 2. Now, for the middle term here, 1 minus cosine square A can be replaced by sine square A from the Pythagorean identity. So that will become minus 2 times, this will be sine of A over 2 plus 1 plus cosine of A over 2. So if we're going to add all these, so since all the denominators are 2, then we have 1 minus cosine of A, and then minus 2 sine A, and then we have uh, plus 1 plus cosine of A. So in this case, negative cosine A and positive cosine A will cancel out. 1 plus 1 is 2. So this will be 2 minus 2 sine A all over 2. Now, if we divide both terms here by 2, then we will be getting 1 minus sine A, which is our right-hand side. So this proves our identity. Okay, and then for our last example, we will have uh, finding the values of sine, cosine, and tangent of these half angle parameters, given the conditions that sine of alpha is negative 2 over pi and cosine of alpha is greater than 0. But in this case, no, we can assume that our angle alpha, we can assume that angle alpha is from 0 up to 2 pi, exclusive of 2 pi. So in here, we need to solve for the values of the half angle of sine, cosine, and tangent. So we need to use the formulas. So we have the square root of 1 minus cosine of alpha over 2. And then for cosine of alpha over 2, we have to use the square root of 1 plus cosine of alpha all over 2. And then for tangent of alpha over 2, we can make use of one of the three formulas that we had earlier. So we can use this one, or we can use this one, or we can use this formula here. So let's use, now for simplicity, let's use this or this one. So let's use sine alpha over 1 plus cosine of alpha. Sine of alpha over 1 plus cosine of alpha. So to solve for these trigonometric functions, we will be needing the value of cosine of alpha. So let's solve it in another slide. Let's remove this first. Okay, let's remove this. Okay, now, so the given information are sine alpha is equal to negative 2 over 5, and cosine of alpha is positive. So in here, since sine is negative, then we can say that the terminal point of alpha is in quadrants 3 or quadrant 4. Now, cosine of alpha is greater than 0 means that cosine is positive, and that means the terminal point of alpha must be in quadrants 1 or 4. So the common quadrant is quadrant 4. So P of alpha is in quadrant 4. So which means that the x and y coordinates would be positive x coordinate and negative y coordinate. Now, since there's an assumption that whenever there's no given interval for alpha, we can assume that alpha is between 0 and 2 pi. So which means if alpha is between 0 and 2 pi and the terminal point of alpha is in quadrant 4, okay, that would mean that alpha is somewhere between 3 pi over 2 and 2 pi. So if we are going to divide this by 2, that means alpha over 2 will be between 3 pi over 2 divided by 2, which is 3 pi over 4, and 2 pi divided by 2 is pi. So 3 pi, if an angle is between 3 pi over 4 and pi, that means the angle is in quadrant number 2. So that indicates that alpha over 2, or the terminal point of alpha over 2, is in quadrant, right? So quadrant 2, that means if we go back in the previous slide, if alpha over 2 is in quadrant 2, that means sine must be positive square root, cosine must be negative square root. So that's the purpose, no, of the plus minus. You need to get the positions first or locations of the terminal point of alpha over 2 in order to get the correct sign for the radical. Okay, now, so let's get the value of cosine alpha because we need this in the formulas. And for sine alpha, we already have negative 2 over 5. So going back in the other slide, so since sine alpha is defined as y over r, by using the relationship x squared plus y squared equals r squared, and y is negative, so that means y is negative 2 and r is positive 5. So y is negative 2, r is positive 5. So using the relationship here, we get x squared plus y squared is 4, and then r squared is 25. So that means x squared is positive 21. And then solving for x, we get plus minus square root of 21. But since the terminal point of alpha is in quadrant 4, then the x coordinate must be positive. So we have to take x is equal to positive square root of 21. So that means cosine of alpha is x over r, which is square root of 21 over 5. So substituting that into this radical, we have 1 minus square root of 21 over 5 over 2. This one will be negative square root of 1 plus square root of 21 over 5 over 2. And then uh, for the tangent, we have sine of alpha, that's negative 2 over 5 all over 1 plus square root of 21 over 5. So simplifying further here, we get this one is square root of 5 minus square root of 21 over 10. And then we can leave this as our final answer. And then this one will be negative square root of 5 plus square root of 21 over 10. And this one will be negative 2 over 5 multiplied by the sum of this, which is actually uh, the reciprocal of the sum of this, which is 5 over 5 plus square root of 21. So this gives us negative 2 over 5 plus square root of 21. So you can actually take care of this by rationalizing this, by multiplying both the numerator and the denominator by the conjugate of 5 plus square root of 21. Now, another thing to point out here is, suppose now that our angle, uh, let's say our angle is cosine of, is 200, let's say 75 degrees. Let's suppose that we're looking for cosine of 275 degrees. The 275 degrees is an angle in quadrant number 4. Okay, now, so cosine of 275 degrees can be written as cosine of 550 degrees over 2. So it's actually a half angle identity, or it's a half angle. So we can make use of the half angle identity. Now, since 275 degrees is in quadrant 4 and cosine is positive in quadrant 4, then we have square root of 1 plus cosine of 550 degrees over 2. And then if we have sine of 275 degrees, then that's going to be sine of 550 degrees over 2, which is equal to negative square root of 1 minus cosine of 550 degrees over 2. So we're using the negative square root because 275 degrees is in quadrant 4 and sine is negative in quadrant number 4. So this ends our video for the half angle identity. So I hope that you learned the techniques in illustrating and evaluating these the trig functions using these identities. And I hope that you learned. And please do not forget to subscribe to my channel. Thank you for listening.